Hey guys, welcome to our first lesson where we look at types of data and cover the stem and leaf display, so the stem plot. All right, so here is shape of a data distribution, and we have a football team, specifically the Pittsburgh Steelers, and I want to know what sort of variable on a football team has that type of shape. So give it a guess. I'm sure some of you know this right off the bat. So our first data set that we're going to be working with is a NFL training camp roster. We have 93 players. I think by the playoffs, they cut it down to like 53 or 55 and 13 variables. So this is the up-to-date 2026 training roster for the Pittsburgh Steelers. So you've got the player name, their jersey number, position type, height. Height is strictly in inches, which makes sense. Normally it's like feet and inches, which makes the arithmetic more difficult. Weight, years of experience, total pay. And we want to be able to classify each of these variables. So categorical is pretty much puts people into groups. You can't do arithmetics on that. So for example, position, quarterback, offensive lineman, defensive tackle, tight end, it doesn't make sense to average people's positions. Position type, so I went ahead and grouped the different positions because there's so many positions into skilled, hybrid, which includes tight ends and linebackers, and linemen. And if you're not familiar with American football, that's totally fine. We can still work on the data. Side, either playing offense, defense, or special teams. Rookie, so either they're playing their first year in the league or they're not, where they went to school. Now, quantitative ones, arithmetic does make sense. So for example, height, we can get a bunch of people, different heights, and we can find the average height of a group. Same with weight, same with age, how old someone is, pretty straightforward. Years of experience, how many seasons have they played in the National Football League? Total pay, how much money they earn. Obviously, these different distributions, if I look at the distribution of all 93 players along these different variables, they show up and they look different. So jersey number is one of the variables, and someone's jersey number is made up of digits. Someone can be number 10 on a football team. Now, a little bit later, we're going to work with programming software R, and I can find the average jersey number of everybody on a team, and I can actually get it because it's a number, but it's a number that doesn't mean anything. So my big question is, if I do arithmetic on something, is it meaningful? And if it's so, it's quantitative data, and if it's not, then it's categorical, more than likely. Now, within each branch, I can have nominal. So for categorical variables, nominal, there's no order, different positions, quarterback, receiver, tight end. In soccer, forward, goalkeeper, defensive player, midfield, wing. The order doesn't matter. In some situations, if it's ordinal, it does have an order. So for example, jersey size, small, medium, large, extra large, there's a clear progression. Freshman, sophomore, junior, senior is another one that's categorical, but it's ordinal. For quantitative data, we have discrete, which means I count. So for example, number of siblings, 1, 2, 3, 4. You can't really have 2.5 siblings. On the other hand, continuous means I measure it. And between any two values, there is another. So for example, height, I can get as specific as possible, and I'm only limited by the instrument that I'm using to measure height. So for example, time, there's always another value in between them. Weight is the same way. As opposed to like number of credits that you take at school, 15, 16, 17, 18. Again, you can't take like 14.125 credits, whereas you can weigh 14.125 pounds. Well, not you, but like let's say some animal. All right, so we have 6 Virginia Tech students, and we have a whole spreadsheet of data that has Virginia Tech students. and it has year, college, residence, GPA, credits, and work hours. And for each of these, you want to decide if it's categorical, quantitative, and then figure out if it's nominal, ordinal, discrete, and continuous. So pause the video, do a quick check for yourself on this. So someone's year, it is categorical and ordinal. So freshman, sophomore, junior, senior, college, categorical and nominal. Residence, on campus, off campus, so categorical, nominal. GPA, so GPA is an average, so it's quantitative and it's continuous. So I can get it as, so normally it's just 2 decimal places, but I can have it as, as many decimal places as I want to. Number of credits is quantitative and discrete. And then number of hours worked, quantitative and continuous. So normally people just tell you how many hours they work. So often it's just given as a whole number, but again, it can be as specific as, like, depending on how you clock in and clock out. So describing distributions, depending on what kind of variables we have, what do they look like? So there are, this lets us introduce some important vocabulary. So left skewed means I have a tail that goes to the left. Symmetric, pretty much similar, kind of mirror images on both sides. Right skewed, I've got that tail on the right side. Bimodal, I've got 2 kind of specific humps. And uniform, it's kind of mostly flat all the way across. So an example of this kind of distribution is I roll a 6-sided die. Let's say I roll it, 10,000 times, and then I look at the distribution. I can have 6 possibilities of what can happen. I can roll a 1, a 2, a 3, a 4, a 5, and a 6. And I would kind of expect there to be a fairly uniform distribution of what that might look like. In the short term, let's say I roll it, 50 times, I expect there to be some variation, but if I roll it 100 times, I expect it to be fairly uniform. Now, Stemplots. Let's say somebody weighs 228 pounds. We're going to go back to the football roster. Stem and leaf, so we'll get to that in a second. Stems go in a column in order, and leaves go beside them, sorted. Empty stems are still drawn. Let's look at the first example here, which is player weight. This is the RStudio's default display. So if I go to RStudio and I do a Stemplot of weight of, I'll say Steelers, and I want weight. So the Steel is just the name of the data set that I have, which is the Pittsburgh Steelers. I'm going to put a $sign and I'm going to say, all right, which display do I want? I want weight in pounds. All right, so you can see I've got the stems 16, 18, 20, 22, 24. And the issue with that is these are going by 20 pounds. So I don't know if I'm starting with 168 or 169 or 168 or 178. So I actually want to, so I'm going to go back to my lesson here. We can clearly see the shape, right? It's that bimodal distribution where you kind of have the skilled position players here, then you have the linemen here. Linemen tend to be heavier, kind of some of the strongest players on a football team, and they just like hit each other a lot. So the issue is like I don't know what these 2 first values represent. So what I want to do is I'm going to break it down into stems that are 10 apart. So I'm going to, we'll talk about later how to break down the stem. So here, now I can clearly see that my first 2 players weigh 178 and 179 pounds. And my heaviest player weighs 342 pounds. So that's a lot more helpful. Now, in my distribution, I have 48 skilled players with a range of 178 to 250 pounds, 19 hybrid players, 226, 265, and 26 linemen. So later on, we're going to talk about how to break down. Notice this is a categorical variable, and I can actually look at a data set by breaking down something like weight, which is a quantitative variable, by a categorical category. All right, so Stemplots. Another example is exam scores from students. So I had 98 students who took a fairly easy exam, and here are their grades. And you can kind of see a left skewed distribution. This is pretty busy. So I have lowest student got a 38, and then a 47, then 58. So here we have a bunch of 90s, 91s, 92s, 94s. And here I want to split the stem. So I want to, like, this is too busy. So now I have the 38, 40, 47, 52. So now the first stem goes from 80 all the way to 84, and the second 8 goes from 85 to 89. And it's a little bit easier for me to make sense of that. And I can like continue splitting it, and that's something we're going to go into later. So next thing we're going to do is we're going to get some of this data into R, learn how to do some of the coding, and that's going to wrap up our first lesson.